everyone. In this lecture today, I'm going to talk to you about the basics of GMP, deviations, root cause analysis tools, and CAPA. Okay, so first, what is deviation? And what is deviation, incident, and non-conformance? Okay, so what are these three terms? Okay, before I go into the details. Okay, so what is deviation, incident, or non-conformance? So basically, all these three means deviation, incident, and non-conformance means a non-fulfillment of GMP requirements. Okay, so non-fulfillment of GMP requirements. It can be so what kind of non-conformance, non-fulfillment of GMP requirements it can be? It can be QMS non-conformance, which means that quality management system. QMS means quality management systems not followed. Product non-conformance, which means that product not meeting specification. And finally, process non-conformance, which means that for process not followed. Okay, so this is the common definition of these three terms: deviation, incident, and non-conformance, which all mean non-fulfillment of GMP requirements. It can be QMS non-conformance, product non-conformance, and process non-conformance. So now in details, so what is incident or incidents? Okay, so this is the GMP non-conformance. As you already know, this means that incident or incidence is an unplanned event that is not part of the standard operation. Okay, so incident or incidence is the unplanned event that is not part of the operation, whereas deviation, as the name suggests, is the departure from approved instructions, procedure, or approved standard. Okay, so deviation is the departure from the approved instructions, procedure, or approved standard. Non-conformance is deficiency in the characteristic, product specification, process parameter, record, or procedures that renders the quality of product unacceptable, indeterminate, or not according to the specified requirement. So this is non-conformance. These are the definitions of these three terms. And the next is that when can deviation, incident, and non-conformance occur? So it can occur as an error during the manufacture of a batch. These can also occur when a batch is made outside of validated parameters. These things can also occur when wrong procedure or wrong equipment, or non-qualified or non-calibrated equipments are used, when the correct procedures is not followed, and also these can occur because of unexpected failure of system or utility, and these can also occur because of receipt of damaged starting material or components, or due to temperature excursion. Okay, so these are the possibilities when the deviation, incident, and non-conformance can occur. So then, what are corrective and preventive actions? Okay, in short, CAPA, it stands for corrective and preventive actions. So what are corrective actions? So corrective actions are the actions taken to eliminate the cause of detected non-conformity. Okay, so corrective actions are the actions taken to eliminate the cause of detected non-conformity or other undesirable situation. Corrective actions. Okay, so these are the actions taken to eliminate the cause of detected non-conformity or other undesirable situation. Okay, so corrective action is taken to prevent recurrence. Okay, so we take corrective actions to prevent from happening again. Whereas the preventive action, or PA, simply is the action taken to eliminate the potential non-conformity or undesirable situation. Preventive action is taken to prevent occurrence. Okay, so we take preventive actions and to prevent something from happening. That's why it is preventive action is taken to prevent occurrence. So these are the definitions of corrective and preventive actions. Okay, CAPA. So what is a CAPA? What is the definition of a CAPA? CAPA is a quality assurance system. CAPA is a quality assurance system which addresses quality events which may occur or could be anticipated to occur during health, healthcare product manufacturing. So basically CAPA is a quality assurance system, and it addresses quality events which may occur during or could be anticipated to occur during healthcare product manufacturing. Okay, so basically what CAPA involves, CAPA is a quality assurance system. It's a continuous improvement CI tool used within quality assurance system. Okay, CAPA is a continuous improvement tool used within quality assurance system, and CAPA also aims to prevent a recurrence corrective actions, or to prevent issue occurrence, that is preventive action. Okay, so CAPA aims to prevent a recurrence or to prevent an issue occurrence. So corrective actions and preventive actions. So this is a CAPA. So what is CAPA? Basically, it's a quality assurance systems which addresses quality events which may occur or could be anticipated to occur during healthcare product manufacturing. So then key CAPA definitions. What is immediate correction? Okay, what is immediate correction? So immediate corrections are the action taken to eliminate a detected non-conformity. Corrections typically are one-time fixes. Okay, these are immediate corrections. Immediate corrections are one-time fixes. A correction is an immediate solution such as repair or rework. Correction is an immediate solution such as repair or rework. It is also known as remedial or containment action. So immediate corrections, they are also known as remedial or containment actions. These are typically one-time fixes, and they include an immediate solution such as repair or rework. So then what is a CAPA plan or program? We should have a CAPA plan or program. So what is it? So CAPA plan or program is a systemic approach that includes actions needed to correct corrections or avoid occurrence. So basically corrective actions, and eliminate the cause of potential non-conforming product and other quality problems. So it's a preventive action. So basically CAPA plan, it's a systemic approach that includes actions, okay, needed to corrections, avoid occurrence, which is corrective actions, and eliminate the cause of a potential non-conforming product and other quality problems. So just preventive actions. So these are included in CAPA plan or program. So then we have to decide, then how do you know that which action is corrective actions or which action is the preventive action? So corrective actions, when to take corrective actions and when to take preventive actions. Corrective actions are taken when only if we already have the product non-conformance or process non-compliance. So to take the corrective action, we should already have product non-conformance or process non-compliance. Okay, we should already have this non-conformance or non-compliance. So for example, product failing specifications, in situations like product failing specifications, confirmed customer complaints, use of obsolete documents, and audit finding. During these cases, we take corrective actions. Okay, during these incidences, we take corrective actions. These are only a few examples. So then, so then next is deviations management, industrial flow of handling of deviations. So how we should handle the deviations, deviation management. So it includes a logging of deviations and description. This is the number one, and number two is the event detection and investigation, and number three, risk analysis and impact assessment. Okay, so risk analysis and impact assessment. Number four is deviation categorization. Number five is root cause analysis. Number six is CAPA, so corrective action and preventive action. Number seven is efficacy of corrective action and conclusion. And number eight is verification and closure of CAPA. So this is the industrial flow of when deviations occurs. This is the industrial flow, how the deviation is handled. Okay. And so now the next important things to understand is that there are different types or different categories of deviations. So these deviations are major deviations. So the categories include major deviations, critical deviation, and minor deviation. So basically three main categories that I'm going to discuss here. So what is a major deviation then? When the deviation affects, the major deviation is the deviation when it affects a quality attribute or critical process parameter, an equipment or instrument critical for process control, of which the impact to the patient, so it's the important thing is here guys, of which the impact to the patients, personnel or environment is unlikely. Okay, unlikely. The deviation is the deviation is categorized as measure requiring immediate action, investigation and documentation. So basically major deviations is the deviation when the deviation affects a quality attribute, critical process parameter, an equipment or instrument critical for process or control, of which the impact to the patient, personnel or environment is unlikely. Okay, so the impact for patient, personnel or equipment is unlikely. So this kind of deviation is categorized as major deviation. What is critical deviation then? Exactly, the definition remains same, the change occurs here. So when the deviation affects a quality attribute, critical process parameter and equipment or instrument critical for a process or a control, of which the impact to the patients, okay, personnel or environment is highly probable. Okay, so impact to the patients, personnel or environment is highly probable. For example, if some deviation occurs and this deviation can impact to the patients, personnel or environment, is highly probable, including life-threatening situation, that kind of deviation is called critical deviation. These deviations also require immediate action, investigation and documentation. Okay, so minor deviations, these when the deviation does not affect a quality attribute. Okay, so the minor deviation does not affect a quality attribute, critical process parameter, equipment or instrument, okay, or instrument critical for a process or a control, the deviation is categorized as minor. Okay, so here the deviation affects a quality attribute, process parameter, critical process parameter and equipment or instrument critical for process or control without affecting patients, personnel or environment. Here the effect is on patient, personnel or environment, but here this kind of deviation does not affect a quality attribute, critical process. The minor deviation does not affect the quality attribute, critical process parameter or an equipment or instrument critical for a process or control. So this is minor deviation. So then quality risk management, guys. Now that I have talked about the categories of deviations, so quality risk management can be used for identification of product attributes and operational parameters which are critical to the manufacturing operations in order to identify their associated risks in advance. So that's why we have to apply the quality risk management. So investigation management. So what is the investigation management? Once the problem is contained, okay, so once the problem is contained, investigate what caused the problem. So we have to initiate the investigation, after once we contain the problem. So investigation is initiated, and so problem investigation. So we should know that problem investigation, it's a science, it's not an art. And problem, it is important to conduct a thorough root cause analysis. If some problem happens, we have to conduct a thorough root cause analysis to identify the root cause, and the leader of the investigation team should be trained in the techniques of root cause analysis. Okay, so another important thing is that the leaders who are leading the investigation team, they should be trained in the techniques of root cause analysis. So initial action, so after identifying the problem, so initial actions after identifying an issue or the problem. So identify what is immediately affected. So we have to identify what is immediately affected, and we ask, does this situation impact other products, equipment, raw materials, components and or systems? So if there is product involved in the event, and we have to identify or evaluate lots or batches run before and after the event. Okay, so we have to identify the batches run before and after the event under investigation. And has any affected materials already been released or distributed to the customers? These are the questions that we ask, and we take urgent actions. So we have to determine what actions can be taken urgently to reduce the risk to the patients, public or the company. Okay, so these actions are called correction. So these kind of actions that determine the action that we take urgent to reduce the risk to the patient, public or company after identifying an issue, these kind of actions are called corrections. Okay, so then corrections examples. So what kind of actions include corrections? For example, corrections action examples include initiate urgent remediation actions, recall product if product quality has been compromised, and we can place the product in the quarantine, stop manufacturing the last resort, and we can also stop leak or cleanup spills, and we can replace the faulty equipment. So these are the few examples of corrections. Okay, and the next topic that I'm going to discuss here is the root cause analysis, a very important topic. So what is root cause analysis, or RCA? Root cause analysis is a key element to site's quality system. Important consideration includes, so when we're doing root cause analysis, we have to pay attention to that has this issue occurred in the past. What is the potential impact on the other batches or the other products? These are the questions we're asking. So we don't start at first plausible explanation. So we have to make the list of all the potential causes that might have resulted the issue, and then complete the process to eliminate any potential causes that can be eliminated. If the root cause is not on the list, then it will never be found. We should know that if the root cause is not on the list, it will never be found. If we don't find the confirmed root cause, we have to address potential root causes and monitor the issue. Okay, so it can happen that we don't find the potential root cause, and in that case we address the potential root causes and monitor the issue. We have to monitor, we have to follow up implemented action. Okay, so steps involved. So then what are the steps involved in root cause analysis? Okay, these are the steps involved: 1, 2, 3, 4, 5 steps involved in root cause analysis. First, if problem occurs, so we define the problem. Okay, so we define the problem, and in second number, we collect the data. We define the problem, we collect the data. In number third, we identify possible causes, we identify possible causal factors, and in number fourth, we identify the root causes. We identify the root causes, and in number 5, we recommend and implement the solution. So these are the 5 steps involved in root cause analysis. So tools of root cause analysis. So basically we can make the checklist. Checklists are really beneficial in providing standard and consistent list of potential sources of error. So we can ask this question: so was the correct procedure followed? Okay, was the correct procedure followed? Was the person who was using the procedure trained in the procedure, or does the procedure match the actual practice? Is this the issue that occurred? Is this a recurring issue, or it occurred the first time? Was there an equipment problem, or was the equipment calibrated? So we can make the checklist and we can ask these questions. Okay, for root cause analysis. So tools of root cause analysis. Brainstorming is a very nice tool in root cause analysis. Brainstorming can be used in association with other root cause analysis tool. For example, Fishbone diagram. So brainstorming is a method of generating. So what we do when we do brainstorm, we generate large number of creative ideas in a short span of time, right? So brainstorming approach, we have unstructured shout out ideas. Okay, we thinking outside the box, structured rotation around the room for the ideas, and we should list every ideas so that we can come back later to the list. Okay, so brainstorming is really helpful method for generating large number of ideas. Okay, so this is also very nice tool in root cause analysis. And tools of root cause analysis. While doing root cause analysis, chronology is something which is really important. So basically, what is chronology? Chronology is the arrangement of events in the order of occurrence. So when the event occurred, if some event occurred first, then we order that first, and the next, and the next, and so on. So basically, this is the arrangement of the events in the order of occurrence. So this helps determine where the problem began. Okay, so to determine, if we want to know where the problem began, then this tool is this chronology is really helpful. Here is an example. For example, in October 12, results within specification. In October 19, floor maintenance and housekeeping was performed. In October 26, for example, high variability of results. The 2 balances were found out of tolerance. And November 2, results within a specification. November 9, results within a specification. November 16, results within a specification. Results within December 7, floor housekeeping performed, and high variability of the results. So basically, we know that whenever the floor maintenance has been performed, then there were variability of the results, and the 2 balances were found out of balance. Okay, so balances were calibrated. So from here, by listing all these events, that we know that, okay, what might have resulted the problem. So floor maintenance and housekeeping, here also that resulted high variability of results, and here also floor maintenance and housekeeping, which resulted high variability of results because the balance, two balances were out of balance. Okay, so by listing the events in a chronological order, we can identify where the problem began. So tools of root cause analysis. Another important tool in root cause analysis is the change analysis. Okay, so what is change analysis? Change analysis, it determines where the change occurred and identify the moment of that change. Okay, so change analysis helps us to determine where the change occurred and identify the moment of that change. It helps for where to look for the potential cause. So basically, change analysis helps us to know where to look for the potential cause. For example, if you look at these this flow chart here, we are this chart here, we have here number of complaints, and these are the months of the year. And as you can see that in the month of May, the number of complaints are really high, and also in the month of October, the number of complaints are really high. Then we now know where the change occurred, right? So probably the change might have occurred in the beginning here, right? So it might have occurred here, or the change might have occurred here. That's why we got these many complaints. So so basically, the change analysis is really important tool to know where to look for the potential cause for the problem, okay, or for the issue. Another tool of root cause analysis is barrier analysis. Barrier analysis, it is the evaluation of current process controls to determine whether all the current barriers pertaining to the problem were present and effective. Okay, so this is the barrier analysis is evaluation of current process control to determine whether all the current barriers pertaining to the problem were present and effective. For example, problem we have here incorrect expiration date on the label, and current controls are line clearance, in process manufacturing inspection, final manufacturing inspection, finally final product release. So why the controls failed? Because item not specifically in the line clearance. Okay, so this is here, items were not specifically in the line clearance in process manufacturing instruction. So no formal checklist for the inspection. That's why control failed. Final manufacturing inspection. So why no formal checklist for final manufacturing inspection? That's why the control failed. And final quality product release. So it can happen that there are no formal checklists for final quality inspection. That's why the that's why the controls failed. So barrier analysis is also a really important tool for root cause analysis. So then tools of root cause analysis is another tool is 5 why. So we have to ask why to identify the root cause. Okay, so verify the original problem. It's a simple tool. It is a very simple tool that can identify causal factors and elicit possible root cause. So we keep on asking, okay, why the problem occurred. If somebody gives the reason, okay, why that happened, and if the reason is there, we again ask why and why and why. So then this tool will ultimately help us to identify what might be the root cause of the problem. Okay, so another important tool, very important tool of root cause analysis is Fishbone diagram or Ishikawa diagram. Very important tool. This tool is called Fishbone diagram because it looks like the bones of the fish if you look at here in this picture. Okay, so in the fish while making the fishbone diagram, to identify the root cause, first we have to ask ourselves, okay, if the problem is due to people, then we list the reasons, okay, what can be the causes due to people or simple men, and the materials, if the material was wrong or outdated, we ask if the problem is due to materials. We also ask method, if wrong method followed or not calibrated, if wrong method followed or method does not match the actual practice. So it can be also due to the method related issue. And measurement, we did not use calibrated instruments, so we also ask this question, okay, to identify the root cause. Machine, if the machine is broken or some part is out of order, or so we can ask we can ask, we can list several possible causes under machines to identify the possible root cause. And it can also be due to environment, because the temperature is not correct, or the humidity is high, or or airlock system is not working properly. So basically in Fishbone diagram we list the possible causes on people, materials, method, measurement, machine and environment to identify the possible root cause. Okay, so this Fishbone diagram or Ishikawa diagram is really important tool for root cause analysis. So another tool for root cause analysis is comparison matrix. So what is comparison matrix? Because comparison matrix is better isolating what is involved or what is impacted in the problem. Okay, so using comparison matrix we know that what is involved or what is impacted in the problem, and we can identify the parts that do not play a role in the problem, okay, by using comparison matrix, so that the focus is only on the why the problem occurred, is not confused, right? So the focus on why the problem occurred is not confused, because we identify the parts that do not play a role in the problem. And this comparison matrix, it allows for a greater ease in asking the questions of why did this occur, okay? So why did this occur? So for example, we can make the chart like this: did or did not, who did it happen to, who did not it happen to. We ask these questions and we list, right? When did it happen and when did not it happen? We list the answers. Where did it happen? Where did not it happen? Who was involved? Who was not involved? What happened? And what might you have expected to happen but did not happen, right? So we make the chart, we answer all these questions so that we can only focus on we can only focus on what is involved or impacted, not on the other problems, not on the other things which did not result in the problem. So that our main focus lies here in what is involved or what is impacted, rather than what is not involved or what is not impacted. So this is also very, very important too, the comparison matrix. And so another, sometimes it's not possible to identify the exact root cause. So in that case, so it's we list the probable root cause. So basically, unless you have indisputable evidence, okay, the definitive root cause may not be found, right? The definitive root cause may not be found. So the most probable root causes or all contributory causes must be considered and, if necessary, addressed. Okay, in the cases when we don't find the exact root cause, then we have to list all the most probable causes and all contributory causes. We have to consider that and we have to address them if necessary. So, and it can also happen that the root cause can never be identified. So that kind of root cause is no identifiable root cause. So in that case, we will not be able to develop a corrective action, right? So then what we do then, we should, in this situation, we must generate a complete investigation report demonstrating the problem solving being used, right, to solve the problem. Even if we don't identify the exact root cause, then even then also we make a complete investigation report, we demonstrate the problem solving being used, and we also must clearly explain that why we believe that we were not able to identify the root cause and what most likely root cause be. So we have to list it in the report, okay? So it is highly likely that we never identify the root cause, but in that situation we follow this, okay? And risk management. So do we always require an investigation? This is the question. So, and the answer to this is that sometimes the root cause is obvious, but not always, okay? So theoretically we should investigate every issue, but however we know that we have limited resources, and we know that not all issues have the same significance. Hence we have to prioritize, okay? So we must prioritize, and risk assessment is one of the best tools to use, right? So we have to prioritize the issue, and the excuse me, risk assessment is one of the best tools to use, okay? So this is the risk man. So do we always require an investigation? So this is the answer to that. So CAPA management, so CAPA plan, corrective action. So CAPA plan or corrective action. So corrective actions must have at least one identified corrective actions or contributory factor for each root cause already identified. Okay, so each corrective actions must include the following: how this action will avoid the recurrence of identification of root cause. We have to recommend interim actions if proposed corrective action is not immediate. we have to implement verification on excuse me, we have to implement verification on how, when and by whom. We also have to make effectiveness check, how, when and by whom. Can this action be extended to other product process systems not yet affected by this root cause? If yes, we have to open a preventive excuse me, I'm very sorry, I have some problem in my throat. So CAPA plan or preventive action. This CAPA plan, this should have at least one identified preventive action for each potential root cause already identified. Each preventive action must include the following. It must include how this action will avoid the occurrence of potential root causes. We have to recommend interventive actions. We propose preventive action is not immediate. We have to make implement verifications, how, when and by whom. We also need to check effectiveness, so how, when and by whom. So what are the different steps involved in CAPA management? So the identification of the problem, non-conformity or incidents. We have to evaluate the magnitude of the problem and potential impact on the company. We have to make the development of an inspection procedure with the assignment of responsibility. So develop an investigation procedure with assignment of responsibility. We have to perform thorough analysis of the problem with appropriate documentation. We have to create an action plan listing all the tasks that must be completed to correct or prevent the problem. We have to implement the plan, thorough follow-up with verification of completion of all tasks and assessment of appropriateness and effectiveness of the action taken. Then we have to close CAPA after effectiveness of the action plan. Okay, so these are the different steps involved in CAPA management. So CAPA process flow, really important. So if there is an event, then we have to investigate. Okay, we have to investigate. If we identify the root cause, then we have to make CAPA plan, and then we have to make permanent corrective action. And we then after implementing corrective action, then we have to check was that effective, and if we find that that was effective, then we can close the CAPA. But the thing is that if event happens, then of course we do corrections, containment immediately, right? But if we are not able to identify the root cause, then we investigate again. Okay, and so root cause, yes, product disposition. If we identify the root cause, then we can also do the product corrections. And here, for example, so CAPA plan and permanent corrective actions, and if it was not effective, then again we have to go back and identify the root cause. Okay, so if it was not effective, so a CAPA plan should include interim corrective actions, permanent corrective actions, and preventive actions. Sorry, I did not mention before. So it should include interim corrective action, permanent corrective action, and preventive action. No, and close effectiveness evaluation, right? So then basically CAPA process flow, it has three parts. So one is investigation part, another is CAPA plan part, and the another is effectiveness evaluation part. So we investigate and we plan. This is interim, permanent, and preventive action, and we check the effectiveness. Okay, was that effective? If we find that is effective, then we close the effectiveness evaluation. So this is the CAPA process flow. So responsibilities and authorities for CAPA system. Then who is responsibility for CAPA system? So we have CAPA initiator, we have CAPA owner, and also quality manager and quality directors are also involved in this CAPA process. So CAPA initiator will initiate CAPA request describing the inputs, and it assigns CAPA owner by or with the agreement of quality assurance. So CAPA owner owns CAPA and is involved in throughout the entire life cycle of CAPA. Okay, so CAPA owner is the one who owns CAPA, and he is involved throughout entire CAPA life cycle. And CAPA owner assembles team of appropriate SMEs, subject matter experts, to analyze the issue, risks, root causes, and determine the appropriate corrective actions and preventive actions and effectiveness check. CAPA owner also ensures actions are implemented as required and within the agreed timeline. Okay, and CAPA owner performs effectiveness. So these are the duties or the responsibilities of CAPA owner. So what is then quality manager do? Quality manager approves CAPA pre-implementation, post-implementation, and for closure. Quality manager also complies CAPA metrics and reports to the quality director, and quality director reports CAPA metrics to the site leadership team. Okay, so these are the responsible authorities and their responsibilities for CAPA system. So CAPA plan, so we have to so what is the CAPA plan includes? So most probable causes of the issues are, after determining the most probable of the issues, most probable causes of the issues, we make the CAPA plan. So we have to put time to fix these issues, and these, then we also need to ensure that issues do not occur again, and we should know that efforts can be wasted if identified issues are not not dealt with. If we don't deal with these identified issues in a correct manner, these issues can occur again. Okay, so these are the things that we should consider while making CAPA plan. So CAPA plan considerations, yes, we have to ask ourselves, is the CAPA plan adequate? We know that CAPA plan requires time to generate. If not enough time, then we should know that system is ineffective, and we have to evaluate if other actions are required. For example, revising a document, and also allow time for evaluation before the preventive actions are agreed. We must know that CAPA must be effective, and if change management is required, we should do so. Okay. Establishing CAPA effectiveness. Okay, we made the CAPA plan, we identified the root cause, and we made CAPA plan, and then we have to establish CAPA effectiveness. So how we are going to establish CAPA effectiveness? So each potential root cause and every contributory factor should have corrective action or preventive action. Okay, every root cause should be covered in the CAPA plan. There can be several root causes, and sometimes corrective action does not address them at all. So who prepares the CAPA plan should be clear. Who identifies CAPAs, verifies implementation, and evaluates effectiveness should be clear. Is CAPA should be described in detail, and explanation of the actions, how they will avoid occurrence or recurrence of the root causes, who and when actions will be implemented, how effectiveness will be documented and proven, and for each corrective action, consider if other systems will be affected by the root cause. If so, preventive action must be created. So to establish CAPA effectiveness, these are some important points that we should pay attention to. And for the implementation of the CAPA, we know that every regulated company needs a clear accountability of responsibilities, as well as adequate tracking system to verify the implementation of each CAPA. Okay, so they should not be confused with measuring effectiveness. Okay, so that means that these companies should need the companies, every regulated companies, they need a clear accountability of responsibilities, as well as an adequate tracking system to verify the implementation of each CAPA, and they should not be confused with measuring effectiveness. Okay, so change control. So have now decided how to fix the identified root causes. Then we have to now make sure that the CA or PA actions and activities will work. The actions will often involve change control. Yes, these actions will often involve change control. If qualification or validation status is affected, then we have to re-qualify or revalidate. If change is to the written procedure without a major change to the process, then the formal change process is followed, and associated training if applicable. The change process is also involved for major changes to the process. Okay, change control is also involved major changes to the process. So we should know that the implementation must not have any adverse impact on the product. Okay, so this should be clear that the implementation must not have any adverse impact on the product. Okay, implementation of CAPA. So frequent observation by regulatory agencies is that CAPAs are not correctly implemented. So this is the problem that the many pharmaceutical companies, they find that the CAPAs are not correct. They means that FDA or EMA, they find these regulatory agencies, they find that the CAPAs are not correctly implemented. The CAPA plan must be effective. The CAPA plan must include description of the actions to be carried out, who is responsible for the implementation, when the actions will begin, who is responsible for effectiveness evaluation, and how the evaluation will be carried out and documented, and when will it be completed. So this CAPA plan must include these points. So effectiveness versus implementation check. Some companies only measure effectiveness by asking, but has the CAPA been implemented, but they do not assess whether the action has really worked. This is really important to check effectiveness. So effectiveness check. Effectiveness should be measured by ensuring the identified root cause does not occur by the absence of the okay. So effectiveness must be measured by ensuring that the identified root cause, it does not occur, not by the absence of the problem symptom, okay, because the problem can be caused by different root causes. In this case, it will need a new investigation. So we have to measure the effectiveness not by the absence of symptoms, but by ensuring that the identified root cause does not occur, because we know that the same problem can be caused by different root causes, and in that case we need a new investigation. How long does it take to measure effectiveness? That depends. Some companies have a fixed period of 3 months, 6 months, or 1 year. If we use fixed period 3 months and the process is performed monthly, we will only have 3 results, which is not large data statistically. Therefore, the recommended approach is to link the time period of the frequency of the process being used. For example, if we use the process frequently, then we have to also adjust the time accordingly for the CAPA. So to measure effectiveness, not for. So then actually the maximizing the repetition to 10 increases the confidence that the process has worked. Okay, so we can increase the repetitions to 10 and to ensure that the process has worked. So from this, what we know, that to measure the effectiveness, some companies can have fixed period, but the recommended approach is to link the time period to the frequency of the process being fixed. Effectiveness check outcome. So CAPA is fully effective, then in that case we have to close the CAPA. If CAPA is partially effective, okay, in that case we have to extend CAPA to allow more time for evaluation, or a new CAPA or additional actions may be required. And if we find that CAPA is not effective, then new CAPA or additional action may be required. Okay, so if we discover that CAPA is not effective. So another really important thing is the traceability. So CAPA package must include traceability. CAPA package given all documented evidence. We should be able to trace CAPA, and CAPA package must include risk assessments, root cause analysis. CAPA package must include a record of CAPA extensions, and it also should include extension approvals. With this, I would like to thank you all very much for listening to this 43 minutes of lecture, and I would also like to thank USB Education and PMQ, sorry, from which with the help of which was data, this teaching material was prepared. Thank you very much for your kind attention.